Solar panels are made of a semiconducting material that will take electromagnetic energy and transform it into electric potential energy. If you've got an isolated atom, you may know from your chemistry class that you have discrete energy states, right? The electrons have energies that are separated from one another. When the atoms are isolated, okay, these are very well separated, and there's one state here and one state there. What's really interesting is when you start to bring additional atoms close by, the neighbor atoms can't have exactly the same energies as each other, okay? They have to be slightly different. So as you add atoms, you're going to get a bunch of states that are fairly closely spaced. And when you reach the point where you've got a solid material in a crystalline form, then you've got many, many billions of atoms that are close to each other. And these discrete states have broadened out into what we call bands. So this is where the electrons would exist in their unexcited state. And then there are unoccupied states that are allowed, okay, from some of these, from the excited states over here that weren't occupied, and a conduction band will be created. And in between, there's what's called the band gap. No states exist here, and it's that gap that varies in size, and that's what distinguishes between an insulator, a semiconductor, and a conductor, right? So here we go. This is the scientist's version of a photon coming in, right? A particle of light zotzes an electron and promotes it to the conduction band. And now that it's an electron that's been promoted to a conducting site, we can hook up stuff. You could put your toaster, right, in here, and you could toast your bread.